Hello all, this is Manoj Deepes from the Department of Electronics and Communication. I'm here to present an internship topic named Design of Power Adapter. So let us continue with the session. And these are my contents: introduction, objectives, certificate, plan of work, methodology, results and discussion, conclusion, and reference. So I have completed my internship in the company named Velankani Electronics Private Limited Company, was established in the March 1999 in Bangalore, India. Headquartered in Bangalore, India's IT capital, Velankani Group is a fast-growing conglomerate engaged in diverse business like information science and technology, infrastructure development, hospitality, electronics. So I have completed my internship from the timeline 2012 9 to 11/10. Let us continue. And these are my introduction. Design is an important aspect of creating any product or device, including power adapters. A power adapter, also known as a power supply or AC or DC power adapter, is a device that converts AC power from a wall outlet into DC power that can be used to power electronic devices. The design of a power adapter involves several key components, including a transformer, rectifier, filter, capacitors, and voltage regulators. So basically, power adapters have become unambiguously in our daily lives, as they are used to power a wide range of electronic devices such as laptops, smartphones, tablets, gaming consoles, and other devices. The main objective of this project is to understand the working theory of diodes, rectifiers, and linear regulators, to design and simulate electric circuit on a simulator, to read the datasheets of the different components in the circuit, to select the suitable components for design, to extract the layout of printed circuit for simulator, then implement the electric circuit on PCB board. So these are my plan of work: week 1, week 2, week 3, and week 4. So proposed methodology: the AC voltage from the mains, it is being transmitted through the transformer, and the output is collected as the DC voltage. The step down transformer is used to transfer the incoming line voltage to the required level of the power supply. The input stage of the power adapter consists of transformer that steps down the AC voltage from the wall outlet to a lower power voltage that can easily proposed by the electronic components. The rectifier stage converts the AC voltage from the transformer into a pulsating DC voltage using diodes. So this is the block diagram. The pulsating DC voltage still contains AC components which can cause the interference with the electronic devices being powered. The filter stage uses capacitors to smooth out the pulsating DC voltage and remove the AC components. This results in a relatively stable DC voltage that is suitable for powering electronic devices. The voltage regulation stage is responsible for maintaining a constant output voltage even if the input voltage or current voltage. So this is my block diagram, which consists of the input AC voltage, rectifier, input filter, transformer, output filter, and the IC. The output is known as the DC voltage output with an voltage of 5 volt and the 500 milliamperes. So this is the input characteristics of power adapter with an minimum voltage of 90 to max 300 voltage, and the input frequency with 47 hertz. Efficiency is 70%. Next, these are the components which we have used: bridge rectifier MB10F, ICCD309F, diode SS14, and transformer ORCAD software, cadence specific viewer. So these are the advantages and disadvantages. Safe advantages are like safety, faster charging, reduced heat buildup, noise reduction, portable and convenient. Disadvantages like potential for damage, dependency on external power source, each generation, difficulty to troubleshoot. These are the applications: powering laptop and charging mobile devices, for medical equipment, and for the security systems, telecommunications. So next is the result and discussion part. After doing all the construction as said earlier, electronic circuits cannot handle high voltage current. So a transformer is used to reduce the AC input and required value and will give the required AC voltage value. Now to convert an AC signal to DC signal, a rectifier is used. The output from the rectifier is not a pure DC output. In fact, it contains a lot of ripples and it is highly not smooth. To make the DC output smooth and remove the AC content of the rectifier, a filter circuit is used. So finally, a 5 volt 500 milliampere PCB assembled and continuity test was performed. So these are the output characteristics with VO with a minimum voltage of 4.5 to maximum voltage 5.5 and with the 0.5 zero point 0.5 amperes, that is 500 milliamperes as output current. So this is the silk screen layer, sensing layer which helps to understand the warning symbols, polarity of the parts, and they identify the test points and they locate the parts through the reference designators and as well identify the number that are unique to the PCB, identify the manufacturer marks or version numbers and so on. Next, this is this is the top layer and the bottom layer of the power adapter. So next is the layer. Assembly layer, it consists of which usually of part of the overall PCB design, like it is a top view of the assembly layer and this is the bottom of the assembly layer, which indicates its size and shape and location of the board, whether the footprints or the symbols. The assembly layer is also to specify the orientation of the components, distance between them, and any special requirements for their placement or mounting. So next is the conclusion. The 5-volt power adapter project is a simple and effective way to provide a stable and reliable power source for a variety of electronic devices. By converting AC voltage to DC voltage and regulating it to a consistent 5 volts, this adapter can power a range of devices including microcontrollers, sensors, small motors. By working on such projects, individuals can gain practical knowledge and hands-on experience in electronics. The project involves understanding basic concepts of power electronics such as AC to DC conversions, voltage regulations, and power dissipation. These are my references for the power adapter project.